The Edifice Complex podcast is brought to you by DCM, the Drawing Specialists, Blue Rhythm Commissioning Software, and Sensor Suite, the future of intelligent buildings.
Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda, most everything to do with buildings, Mr. Adam Muggleton. Say hello, sir, Yoda.
Hello there. So, interesting one today, right?
Always.
I have mixed feelings sometimes on academics, but academics that do research in the area that I'm in is always super interesting to me.
For sure. So today's guest has published over 130 academic papers, 2 textbooks, and modeled or designed numerous buildings from Uganda to Manitoulin Island. That's kind of cool. A few of his specialties include applied building performance simulation, occupant behavior in buildings, and adaptive learning and building controls, which is part of an annex, international annex. We'll talk about that. High performance building design, which includes solar energy, daylighting, and shading. And one of the projects that intrigued Adam and I, and I've been stalking him actually because of this, had to do with a data mining project that he did with a student of his, Hannah Villeneuve, looking at words that guests from Airbnb had used to describe the indoor environmental quality. And I thought that was an absolutely brilliant idea. And so welcome to the show, Dr. Liam O'Brien. It's good to have you on.
Thank you so much for having me. I'm looking forward to the next hour.
Liam, you earned your PhD in building engineering from Concordia University, and I know a few professors there. But you did that after attending the University of Toronto, where you received your master's in aerospace engineering, and then Ryerson University, where you earned your bachelor degree in aerospace engineering. You're our second guest to come up through the aerospace sciences. What drove you initially into that field, and why did you switch over to the dark side and into building sciences? Tell us your story.
Absolutely. So when you're 18 years old, you really don't know what you want to do. And my thinking was Earth is sort of finished, or, we've figured it out and it's kind of boring. And the next avenue is in space. So I thought, we've solved all the problems on Earth, which was very naive, especially in retrospect. And, aerospace sounded pretty cool. And I did the undergrad in it, and that was wonderful. And it still gave me a great introduction to things like heat transfer and thermodynamics. So it wasn't a total loss, I would say. It's a really good foundational degree. Also fluids. So all these things could apply to buildings, but it still took me a while because I got into a master's program at U of T, and there I designed deployment devices for satellites. So actually, I think something like 5 of my devices have been launched. They were launched from India. They pushed a satellite into orbit, and that was the end of their purpose. But again, you can see the connections to buildings. It took me a while to get there. But satellites are really self-sufficient devices, right? And so that's what got me into buildings, because I was interested in this idea that we could have self-sufficient buildings. But what happened is I realized in the evenings, I was not reading about aerospace, I was reading about buildings. And so on a whim, I applied for a PhD in building engineering at Concordia, which is essentially one of the only programs in building engineering in Canada, or it was at the time at least. It's growing. And to my utter surprise, I was accepted into the program without a lot of hesitation from the supervisor. And I realized, he had blind faith in me, but I think it paid off for everyone involved.
And who was your supervisor there?
That was Professor Andreas Sathianidis. And,
I've known him for, probably 30 some years through his work with ASHRAE in our committees. And, he's contributed a lot to the field. That's for sure. There's no doubt. There's a handful of people in Canada that have done great work. and he's one of them for sure.
Absolutely. He's a legend in the solar area. And then I had a co-supervisor at U of T, Ted Keswick, who you may know. And he's also quite a character and a legend in building science.
Wow, Ted doesn't pull any punches either.
That's right.
Just for our younger audience or anyone thinking of doing a degree or a master's degree. So what you just described there, like your amazement at getting accepted into the PhD thing. I was like that when I got accepted for my degree and my master's degree. I'm thinking, wow, I didn't think that would happen, you know, because it's imposter syndrome, right? And then you're even more amazed when you get to the other end and get your certificate and your mum's hugging you and crying, right?
That's right. So now that I'm on the other side, I realize there's actually a shortage of people who research. And I think a lot of students who have done their engineering degree, I mean, that's a professional degree, right? They can go become a professional engineer. So why would you take another 2 years for a master's or another 4 years for a PhD? Well, I think it's not always obvious right after your undergrad, but in fact, the amount of freedom I have, I mean, I can speak my mind virtually, and you know, I set my own schedule and I can work on what I want as long as it's fundable. And we can talk about this later. You know, I can do what I want, and that's incredible. So I wouldn't change anything for the world. But I understand if you're in debt from your undergrad, the hesitation to go on. But at least in my case, you know, I would never do it differently.
Yeah, it's interesting because I've sort of got mixed feelings on PhDs. I did my bachelor's and master's back to back, and at the end of it, I was just exhausted. You know what I mean? I couldn't have faced writing another paper. I'd have killed myself. But I think if you could do a PhD, you've really got to be going into research or teaching, right? That's the real value of it. You know, you're trying to be a thought leader, push the envelope out. Otherwise, don't do it, right? It's my opinion.
That's right. And I've heard that even, you know, a PhD can be a detriment for salaries because employers think, oh, this guy, you know, is going to want to be very narrow and thinks he knows everything. So I can't speak from personal experience, but certainly to go into research or teaching, you know, a PhD is practically a must in engineering.
I want to give a shout out as well to you for a couple of reasons. One, 130 papers, so kudos. That's a lot of work, right? And 2 books, so tip of the hat for that. And also, you know, you're a professor, right? So most people's idea of a professor is they're in this Ivy League, they're smoking their pipe, having big thoughts in their lovely wooded paneled office, and you're in an office with a stepladder behind you. Well, I'm calling Kevin. And, you know, that is awesome. So I love the fact that you're in buildings and your office looks like you're in buildings and you look like you might shoot up in that ceiling in a minute and check something out. You know what I mean? I love that.
That's exactly why it's there, in fact. So we can talk about this later, but a lot of my research is very hands-on, dealing with real problems, because we've realized that a lot of the research opportunities come out of looking at what's done in practice.
Yeah.
You know, just to give an example, I had a grad student who went to a training course with a local controls contractor. And what he learned there was, you know, the way things are being done are, I would say, suboptimal. I think we can all agree on that. And maybe to put it mildly, but out of that, he came up with new ideas to solve those problems. And he never would have understood the problems if he just read papers and textbooks and so on.
Yeah. Well, I know Adam and I, of course, practitioners in part. A good part of our careers have been practitioners in the building end of it. And, you know, the control side of it, I tell you what, you know, from a design point of view, you can do all of the load calculations as accurate as you could ever do. And you can do as much thoughtful design, converting those loads into flows and looking at pressure differentials and all the stuff that goes into engineering. And it can be perfectly installed as per your intention. But if the controls aren't right, you're screwed. It ultimately drives everything. In fact, I don't know about you, Adam, I know towards the end of my career, we actually worked with the control manufacturers off the shelf catalog items and designed around their systems. rather than design custom mechanical systems and try to find a control strategy that worked. That never helped us at all. It drove us nuts, in fact. Yeah. Adam, I don't know about you, but
Yeah, I agree. It's controls is the voodoo, right? So it's this
Yep,
black
it
box,
is.
and some wizard walks out of a laptop, sticks his head in a panel for a day. He's banging away his keyboard. He could be playing solitaire for all I know, but it's just magic, right? It's voodoo.
well, there's a reason why they put a lock on it, right?
But see, this is the thing for me, right? There is a real need for research, but you've got to bolt that on to applied experience, like your student, right? So this is the ivory tower thing where it don't work for me. Research in and of its own, in its own bubble, that's just mental masturbation in a way, right? You've got to bolt it onto experience. You've got to bring the applied. This is why I love building science. It's not theoretical, like theoretical physics. It's science and applied. It's applied science, right? There is a Venn diagram there. And it's in where them things interact. That's where the action is, right?
Yeah, absolutely. And as I said, we've learned a lot of, suboptimalities from looking at real data. And we've been extremely fortunate at Carleton. I'm sure you know Daryl Boyce, former president of ASHRAE, and he was the associate vice president at Carleton. So he was extremely supportive of research to the point where my students have been given the privilege, some of them have been given the privilege to tinker with the building controls. And even if they don't go in and directly change things, we have meetings with the operators where we point out, things that could be improved. They fix it. My students have the benefit of, seeing the impact. And as we like to say, a lot of the students have paid for themselves many times over because the energy savings they've achieved have exceeded their entire salary. And I don't want to say their salary is low. Quite to the contrary, they've found opportunities that are very valuable.
Yeah, that's sweet. So you're involved in a couple of annexes that I'm really interested in, and I apologize because I would love to participate in them, but my hands are full and I can't. And that's through the International Energy Agency, and one of them has to do with the occupant behavior. And fill us in on tell us about how the annex got started, and what you guys have learned to date in a sort of a short story, if you would.
Yeah, absolutely. So for people that aren't aware, these annexes, the name is maybe a little bit strange and confusing. It's sort of a 50 to 100 person team of researchers. They could be from industry, academia, government, etc. And they work together on a big problem that's of international scale. And so several annexes ago, and I should say there's maybe 10 or 15 running at any given time, but they're on all sorts of things like microgrids and natural ventilation. The one I lead, co-lead, is on occupant behavior. But over the last 15 or 20 years, researchers have realized that occupants play a big role in performance, especially in certain building types, right? So not so much in our big institutional buildings where you can't open windows or adjust thermostats, but in residential buildings or in milder climates where we have natural ventilation, occupants can make a huge difference in building performance. And actually, this is what I learned from my PhD. I hope you don't mind. I'm jumping around here a little bit.
No, it's good.
So during my PhD, I made a design tool, like a software-based tool for passive solar houses. And what I realized is that things like insulation specifications and HVAC, rival things like set points and how people use blinds and windows and appliances and so on, such that we really need to better characterize occupants. So that is how the journey has gone. Sort of engineers who traditionally deal with, HVAC equipment and envelopes have started to recognize there's this whole human side that we need to deal with.
What a concept. What a concept. Yeah. Let's think about the people that we're designing for. Whoa.
Absolutely. And And as you know, I'm sure you know, even the world of thermal comfort has changed from this engineering approach where we can perfectly predict how many people will be dissatisfied to recognizing that there's behavioral aspects, there's psychological aspects. And so we know, for instance, that giving people control over their environment will kind of relax their demands on conditions, which is, kind of mind-blowing to engineers, right? And it goes against everything we think and we like. So anyway, the Annex 79, which I co-lead with Andreas Wagner of Germany, and many other researchers from around the world, focuses on kind of the science of people and behavior and comfort. But it also looks at how can we take data from the built environment and generate either new knowledge or improve our building controls. So knowledge in the fundamental sense, whereas another thing you can do with data is, online learning, and you can adjust schedules and set points and all sorts of things to provide that so-called theoretical optimal condition for people.
Yeah. Well, and it's interesting. Adam and I met a long time ago, and we were talking, and one of the things that we bonded over, had to do with balances within buildings and the instability created by imbalances and how people respond to that, and opening windows and doing what people will do, whatever they can to create an environment where they can sense it and perceive it to be comfortable. And comfortable is a broad term, as we know. It can includes lighting, sound, whatever, right? Anything that the human body can sense, there's a level of comfort to it. And what, in my career, and I was, I was not an academic, but I was always questioning why the hell was it whenever, Adam, maybe you were the same case, when you would design the codes and standards, and at the end of the day, you'd still get people pissed off at the building, right? So it didn't matter how good your designs or how compliant you were, we still had problems. And that's when, and it was back in 2002, I think it was, after I'd sold my business and I started up my engineering practice. I said, there's something missing here. And it was through Dr. David Schletzley at Arizona State University. I came across, and he was also a member of our committee that Andre is on, and he had a student there that was studying human physiology and psychology as it related to the built environment. And I looked at his website. I said, "Well, this is it. This is the difference between, or the missing link between the buildings that we design and the mechanical systems or lighting systems or whatever, and the dissatisfaction that occurs in buildings. It's the people." And that's when I started to study human physiology and psychology and said, okay, we need to teach this shit to engineers and architects. But you've done it on a more formal basis and have come up with some pretty interesting stuff. One of the other studies that you did was this data mining of Airbnb. Could tell us about that one, because I think that was one of the most, out of all the shit that I've read over years, it was one of the most brilliant ideas to get data in a fairly low cost way.
Yeah, it's open source, right?
Yeah,
absolutely.
So tell us about that.
Totally. So like most of my ideas that end up doing something good, I just experience life. That's the beauty of our field. And I'm really not envious of people like physicists who can't even see what they're researching, right? But in our world, we can live it and breathe it. And in that case, I'd experienced a few really uncomfortable Airbnbs. I think of the one in Portugal where there was jackhammering and we had to leave. Like, we literally left the city, which turned out to be for the best anyway. But then I started looking at past reviews and I realized lots of people are complaining about this. And then I started Googling and realized someone has actually scraped all of the Airbnb reviews ever, or at least for the past decade or something. And my colleague was dabbling with text mining, and I realized, wait a minute, we could apply text mining to Airbnb reviews to learn about things like the relative number of complaints about the different domains of indoor environmental quality. So instead of going through all these reviews, we could look at Canada's 1.35 million reviews that have been left. So that is reviews for Canadian Airbnb units. And look at things like how many times are people complaining about thermal comfort or noise or indoor air quality. So I had a very brilliant first-year student, I still can't believe this, first-year student in environmental engineering, Hannah Villeneuve, and she analyzed all 1.35 million reviews. And I mean, I can tell you some of the interesting outcomes. So one of them was that about 5% of reviews complained about comfort. And you might think, oh, that's not that much. But the question is not asking people, are you uncomfortable, right? It's asking you to provide an overall opinion of the stay, which could include things like communication with the host, things that are unrelated to buildings. So I think 5% is actually quite high, right?
Yeah.
And then there were more acoustic complaints than everything else combined, compared to thermal, visual, and indoor air quality. But it was tricky. So just to give you some examples of where text mining can flop, we had to look for terms that might indicate comfort. So she looked for things like dim and dark and smelly. And so one person or quite a few reviews actually talked about dim sum, the food, which has nothing to do with visual comfort. And then I got a warm welcome, which has nothing to do with thermal comfort, of course. So it's quite messy, right? And I would say, the analytical side was great, but there's also value to looking at what I call small data, like read individual reviews.
Yeah.
So a few people complained that the thermostat was not actually in the unit; it was remotely controlled by the manager, which is understandably very annoying for people. So I think you can learn more from reading a few comments sometimes than looking at 1.3 million reviews.
But this is such an interesting field here, right? Because this is where you're getting the collision of building science, like data mining, open source research. It's all colliding here in a good way, right? And of course, you can get false positives and blah, blah, and that's part of data analysis, right? You got to weed them out. But wow, what a great thing. Because I gave a talk once and then people were complaining, same thing, brand new LEED Gold building, why does it suck? Right, was basically the question, and I'm paraphrasing here, right? So my thing was, I put up a picture of a stool with 3 legs. I said, look, we've all just gone through leg 1, which is design construction. There it is, and everyone's run away like it's a crime scene, right? So in come the FM team. But there are 2 other factors here, right? There's maintenance and operation and occupants, right? So now you're getting into the field of chaos theory because, because it's LEED building, they're trying to put local controls, so everyone's fiddling with everything, right? Oh, it's a new LEED building. Everyone's fiddling like crazy, and these little chain reactions are starting, right? So someone's cold, then someone else gets cold, and someone whaps up that, and they get hot, and this whole chaos theory thing goes on. So I was trying to explain to them that it's not just handing it over. There's operational issues are like the 80% here, right? Because for 25 years, I can tell you that building team are not coming back ever. So, what do you do? And it became down to an issue of training. I was trying to get them to lock the BMS control set points. Couldn't get that to happen. Because what you're saying to someone, here's this. Imagine someone giving you a brand new stereo system, so that's showing my age here, and then saying, I've locked all the controls, you can't change anything, right?
Exactly.
So this leads on to my other theory and you're probably at the edge of this, and I'll stop talking about it, but I get fired up about this, right? You've got the 3 stalls all sort of like have to interact well to get a great outcome, right? You get chaos theory. So is the answer to this algorithms that are perpetually like scanning, scraping for information, and then making these adjustments in real time? Is that where it goes?
So I have a lot of opinions on this. If I put my engineering hat on, yes, we can optimize everything.
Yeah.
But then you bring the human in, And I want to say, I don't think we should blame people at all, because as Robert said, they're just trying to improve their comfort. Yeah. And for the most part, they don't care about building performance, especially if they don't pay the bills. Yeah. And I think that's legitimate. And if we look at the relative cost of or value of comfort versus energy, it's a no-brainer. But if we automate everything, we take control away from people, and then we lose the benefit of perceived control. So I think there's a balance, right? We shouldn't try to take control away from everyone, and that includes the operators. Like there needs to be some human input. But at the same time, I think we can automate part of it. And I'll give you an example at my house. I have an Ecobee thermostat, and it has learned that it needs to start ramping up before the set point increases, right? So sort of an optimal start algorithm. And I think that's a great example of optimization, because it doesn't really bother me at all. It's for the best that it starts ramping up. But if it took control away from me and my ability to override the thermostat, I'd be really pissed off. Yeah. Because there's going to be days that I'm, working out in my house, or I go for a walk and then I'm too warm inside. And I don't think an algorithm is going to figure that out in my lifetime. Prove me wrong, but I really value being able to override it, and I think operators do as well. So in brief, there's a balance. There's a sweet spot between automating everything and having some manual control.
You're bang on there, because I did a job in Canada years ago now, 10 years ago, and it was heavy concrete mass, radiant heating and cooling, displacement ventilation. It was so goddamn sustainable, it was ridiculous, but there was very little user control. It takes 24 hours to move that building like 1 degree, So, and it was dead quiet, right? So people are used to having air blown at them. So people move in, I'm happy as hell, because I'm looking at the BMS trend lines and everything's like constant temperature, humidity's great, everything's great. And people are complaining like crazy because it's too quiet. They can't adjust anything. And they feel they're not in control of anything, right? Yeah. So it ticked every box known to mankind for being sustainable and optimal and under control. And no one liked it. And there was a dichotomy, right?
Absolutely.
Yeah. Part of that is a cultural thing too. So, we keep threatening if we try to get Mark Pauls on from Manitoba Hydro. And, and I don't know, do you know anything about the building, Liam?
Yeah.
Yeah, right. So cool building, right? So same thing, Adam, right? All radiant heating and cooling, displacement ventilation, also natural ventilation. And it took them almost 2 to 3 years, not just to get the systems, working the way they were supposed to, but also to condition the people how to live in that building. And for our listeners, you need to understand that 2 years is not unreasonable to commission a building that big. We have houses in our portfolio that take just as long, So, and that's important to understand. I mean, you can take a 15 or 17,000 square foot custom house or a 34-story high rise, and they will take the same amount of time to commission. So people need to understand that. But the part that's different is that when you take a custom home, you're talking maybe 2-4 people that you're training versus hundreds of people. Yep. And it's a completely different environment. And, guys like Mark, who were, he actually earned his engineering degree while that building was being commissioned, by the way, which makes him really interesting. Yeah. But, they talk about, and one of the interesting things about that was that all of these sub offices that Manitoba Hydro had were consolidated into the big building, right? So you have groups of people that were living in a culture within that small sub branch coming together as one group in a big monster building. And so there was a whole bunch of social stuff that had to be addressed. And that's the human factor that we have to deal with. That we don't teach that, right?
Absolutely.
Yeah.
And I think there's so much opportunity to bring fields like human factors and industrial design into building engineering. And I have a few students dabbling in that now, and I had one who was co-supervised by a professor in industrial design. And you can't imagine how many insights that student left with compared to someone that's only trained under me or only trained in industrial design. So I think that's where the opportunities are. Because they have terminology that, you know, I've never learned except through my readings, but not through school. Things like affordances, kind of the opportunities that people have, and the techniques that they have as well. So for instance, they have a technique called Think Aloud, where you ask people to perform a task, like try to increase the set point on your thermostat, and then the participants have to say, you know, what they're thinking, what their logic is, what they're seeing, how they're responding. And so that's a way to sort of gain insights about the thought process of people. Because I think as engineers in the field, we forget how people understand buildings, right? There's a lot of myths, things like, you know, if you crank your thermostat, then the temperature is going to increase faster. And we forget about a lot of these insights. Mm-hmm.
Not in a heavy mass building, it's not. So that's fascinating, right? So I've got this Confucian respect for teaching. So because you had the ability to like really influence on a medium long-term basis how things roll out, right? So what you say actually matters, what you teach actually matters. So my lesson learned from that building that I was talking about, where everything, as far as I was concerned, was all good. This was the resume polisher for me, right? And my takeaway from all that was, because it went south pretty quick when the people moved in, was what we should have done, should be in the useless word, we should have got everyone in a room when they all moved in and explained to them why this building was different. Because culturally in North America, if you're not getting cold or hot air blown at you, something's wrong, right? That's just the culture in North America, right? And that was basically the problem. It was super quiet, and because it had triple glazing and everything, it was super quiet, and people were just not used to it. Right?
Absolutely, and I think that's the trend of our buildings, right? We're taking the plant and moving it further and further away from the people. Yeah. And you might think that a perfectly quiet building with, you know, nothing in sight, no thermostat, no light switches would be ideal. But again, that's where the engineers and architects may be a little bit wrong, right? Because people want the feedback. You want to know that if you do something, that the building's going to respond the way you expect, so that you can move on with what you're trying to achieve that day.
This is why Robert's getting triggered a little bit, because this is what he's always been going on about. You know, IAQ, it's not just a temperature on the wall, you know, which is only monitoring, you know, certain things, not even all temperature ranges, right? It's not resultant temperature. So there is a real disconnect at the moment, I think, between what engineers and architects are producing and what people want or need even, right? There's the human factor is just so disconnected in the design process. And that's because it's all been siloed up, right? Design hands to construction, construction hand to FM. Everyone's running away the minute they hand it over. You know, don't get all triggered if you're listening, unless you're an architect. I don't run away. So you do, because it's a fantasy. If you think the design team and construction team are involved post-occupancy, you are smoking some seriously good stuff, right? That does not happen unless they're bought there with a money incentive.
And part of it, you know, is our own problem too, because, you know, I mean, I've had a soapbox now for almost 15 years about how academia and government, particularly health-focused agencies, have corrupted the minds of practitioners that indoor environmental quality is air quality, or air quality is a proxy for IEQ, and they forget sound, they forget odors, they forget vibration, they forget the thermal element. And, you know, so as soon as someone says, well, what's the air quality like? And they're thinking air quality represents all of that, right off the bat, we've lost. Yeah. You know, because the brain will integrate all of the sensory systems, but we have to treat each of them individually. So And this is the beauty of integrated design, right? So when you look at window to wall ratios and window performances, okay, so now you've got lighting that you have to consider, right? But that performance of that glass under extreme temperatures has a surface temperature. Now you've got a mean radiant temperature issue. So now you got a thermal comfort issue, right? Then depending on the solar heat gain coefficient and shading, you've got shortwave radiation coming in, hitting, say, a synthetic floor, breaking it up into particles and gases. So now you got an air quality problem, right? Like you cannot separate any of this stuff. But if we're only teaching people that IEQ equals IAQ or IAK is a proxy for IEQ, we're screwed.
Absolutely. And I'm glad you said that, because when I started at Carleton, I was teaching an IAQ course, and I said, like, I petitioned, and it didn't take much pushback because I think I know what I'm talking about. But I said, no, this has to be IEQ. We need to deal with all these different domains. Yeah. And unfortunately, like when you're first teaching, you have to teach them a little bit separately. But every single lecture, it's easy to come up with an example of where there's unintended consequences. So one improvement for one domain of IEQ impacts another negatively. And the example I like to give is carpets. We put in carpets maybe to improve acoustics, and inevitably they dampen sound and reduce impact and so on. But now you're collecting dust on the surface. There might be impact on thermal comfort. It might affect the way daylight comes into the space and so on. So I completely agree. And I think acoustics is a big missing piece. If you look at the number of professionals that deal with visual comfort or thermal comfort or indoor air quality, it's significantly higher than if you look at people who are experts in acoustic comfort. And I don't know why that is. Is it because, we have systems that supposedly provide thermal comfort, whereas we don't have a system that provides acoustic comfort? I don't know. It's also a lot more complex in my view. I teach all of these, and I think acoustic comfort is trickier, right? It's dealing with a log scale. And generally there, at least from my view, there's less sort of introductory material out there to teach it.
The Edifice Complex will continue in just a moment.
Can you find the drawing and supporting documents you need in less than a minute? Now you can with Echo. It's simple. Just type what you're looking for and press enter. Echo knows your building. Speak with a drawing specialist today. Ask about our special offer of painless onboarding plus 6 months free with Echo. Visit podcast.thedsoffer.com. That's podcast.thedsoffer.com.
And now, back to the show.
All of us, this is my NLP training coming in here, there's three sort of main sensory intakes we deal with most of the time, right? And we have a bias to one. So I'm visually biased. Some people are auditory biased, some people are olfactory biased, right? But that all plays into an occupant sitting in a room with a smelly carpet or dead silence. So going back to that job that I thought was the pinnacle of my resume, we had to put in white noise.
Right.
Just going mad because it was so quiet. It's below NR 3025. It was just library level stuff, right? And we thought that was amazing as a design team. We thought we nailed it.
And then you get, and we also see the opposite, right? Because of, if you look at on a continuum, where IAQ was identified as being a huge issue. And so if you go back, say 15 years ago, and the solution was to remove the synthetic materials, the soft materials. So we ended up with glass, concrete, steel, wood, basically materials that didn't absorb sounds. So in the process of solving the IAQ problem, then we created a sound problem. And so in Adam, in your case, you guys like solved the sound problem, but it was too effective,
Isn't there some right? So I would love to think, I'm sure it's not like this, but in my mind, you're in the back cave of brain trust power here, right? Is there like a nominal optimal design thing you're always working on? Like, are you asking yourself and your research team, what is the optimal design solution here? And you're tweaking with the IAQ, the IEQ, all of that. And there's this like zone where 80, 90% of people are good.
Yeah, so to some extent we're doing that. I have a few students trying to model everything simultaneously. So model the different kinds of IEQ as well as energy to apply that to a parametric model to understand, okay, what happens if I change one surface? How does that affect these various outputs? And so we're working on that, absolutely. But it's a work in progress, I will say.
And it never stops, right? Because you're always forever tweaking it. But it would be, I'd love to read a paper. I'm not a nerd, but that would nerd me out. I'd love to read a paper that said, what does that 80-90% bubble look like? What are the parameters within there? Because that would be a design parameter you could think about, right?
Well, we know from our work that if we can get buildings that have surface fluxes of less than 10 BTUs per hour per square foot, which whatever that works out to in watts per meter squared, I don't know off the top of my head, that architecture lends itself well to good lighting, good sound control from outside to inside, thermal comfort, and air quality. And so that number actually drove the whale graph that we developed, which looked at things like exergy, which is under the IEA annexes, but also the indoor environmental factors, but then human factors. And what we found is that when you can get buildings like that you can condition them with fluid temperatures that are, around, I think our numbers were 77.5 degrees Fahrenheit plus or minus 22.5 degrees Fahrenheit. Basically, you don't need any temperatures higher than the skin temperature of the human body to condition a building. So this use of 190 degree Fahrenheit or 200 degrees or 175 it's just not necessary.
So they become low exergy buildings by design, by default.
Exactly. Yeah. And so one in our paper we said, you could take almost probably 80% of most energy standards or energy codes and burn it simply by saying that the project shall operate for heating and cooling with fluid temperatures of 77.5 degrees plus or minus 22.5 degrees Fahrenheit. And that's it. And then let the architects and the engineers figure out how to do that, because that's what they're trained to do. And then what it does is it drives energy, it drives the indoor environment, it drives all of the human factor stuff. And one sentence.
Absolutely. I couldn't agree with you more. And there's a case where my grad students are working in a space that was originally intended for a single person, I assume. And so there's a high temperature radiator on the ceiling by the window, which is all good if, you're sitting 10 feet away from it or something. But when you cram more people in, then people are forced to sit under this 70 or 80 degree Celsius radiator. And, that's not pleasant, especially for people like Adam and I who don't have the insulation there. Yeah. So it's also a big comfort issue.
See, for that is a design flaw, in my opinion, right? But this is why the building sector sucks a lot. There's no real consequences for bad work, right? It has to go catastrophically wrong for you to wind up in court. But that example there, right? That building was done and handed over, and no one knew enough to know that was going to be a problem. When it was a problem, there's no consequences. Right?
Yeah. And I'd like to give you another example, because this one I'm quite proud of. So my office is kind of west facing, actually where I'm at right now. And there's days in the summer where I need to leave, around 3 o'clock because the glare is intense. And my blind fabric is like fairly transparent. So I can see the sun right through the blind. And I get warm. And of course, we know that if there's bright light and you're already warm, it sort of compounds, right? Because now your body thinks, okay, I'm in the sun, even if it's not really impacting you. So in another building, I was at the design table because I like to get involved in design because I like to question things, as we do. And I showed a picture. I'm like, look, like you cannot use the same blind fabric because like I leave early. And if I leave work early and I go have a beer, the cost of that is quite high, right? Probably a couple hours off for me is the same cost as the blind. And not to get too specific, but the architect said, no, we need it to have a certain look from the outside of the building. I thought, no, the blinds are not for the outside of the building. It's for the occupants. And I was very pleased because Daryl Boyce put his finger down and said, nope, I've got enough evidence here. We're going to choose a more opaque blind. And that was that. But you're right. A lot of these lessons learned don't come back into the next generation of buildings.
Yeah. You mentioned, I want to come back to one of the statements you said about the radiator and the ceiling and sort of a sidebar to that discussion. Do you know, is it Marianne Touche from University of Toronto?
Yes, I work closely with her.
Yeah. So anyways, they did a study where they were looking at low-income housing, high population density in a room, and how it forced everybody to the perimeter, right? And so, the post-occupancy surveys were terrible. I mean, and part of it was the size of the condo or the apartment, the number of people that were in the condo, and how it moved everybody, like beds, for example, out to the outside windows. And so you end up with the downdrafts and all of that type of stuff. And I thought that was a great, intellectually, we know this shit, right? Like, this is not rocket science, right?
For sure.
But until you do the study and you look at, okay, well, this, obviously it makes sense that these people are complaining because of, look at what's happening, right? Crappy building, there's no perimeter zone to stay away from. You're actually engaged in the perimeter zone. And as a result, you're subject to the fluctuations. And then we had Jennifer Veach on. Do you know Jennifer?
Yes.
As well? I thought you would. And another great interview that we had, because she has such a broad knowledge. And one of the things that impressed me about her was her dad was an interior designer. Was that right, Adam? I think if I remember correctly.
Yeah, he was, because she had that perspective on everything, right?
Yeah, so she had that. And so I love the fact that she had that background, but also her studies in human physiology and psychology. So when I think about you, in terms of Canadian scientists that are looking at this stuff, you, Marianne, and Jennifer, three awesome brains with great practical skills. Why are our building codes still such a mess? We've got all this brain trust in this country. Why do we still have to deal with the crap that we have? Why are we letting builders and architects with the blinds still do this kind of shit when we have such great knowledge in this country?
It's a good question. And before I try to answer that, I want to just point out for your perimeter in the low income MURBs that you mentioned, like if you want to put a price on comfort, consider the square footage that's lost because people don't want to use that space at all. Yep. And I heard a great term from Kim Presnell, who's also at U of T, Toronto. Right. And he coined the term, I believe he coined this term, no-sit zones. So basically spaces you just don't want to sit down in your home. I really like that.
So there's a question on the floor I want you to answer, but I'm not going to let you go on that one. But on what you just said, Adam, you and I had, what's his name on? Oh, shoot. Doesn't matter. Anyways, we were looking at these no-sit zones, and we actually were looking at the cost. So if you said, it's $200 a square foot and you've lost 40% or 30% of the floor area, your actual cost per square foot of usable space, like it bumps up like 60 some odd percent. It's not like $200 a square foot anymore. It's like $280 a square foot. And the rest of that is useless space. And so if you think about one office, in one office tower on one city block, and you said, okay, well, there was a waste of capital, right? There's a huge waste of capital because you're building spaces that people can't use. But then there's the environmental cost as well. There's the mining of all the materials to make all the shit, the wood that's harvested, whatever, right? And so if you think about this and you start to scale it up, that's one office in one office building in one city block. How many offices are like that in the city? And how many cities are like that in the province or the state? And how many states or provinces are in the country? You know what? It doesn't take a rocket scientist to figure out how, well, I want to use a real foul word here, how effed up these no-sit zones are to our economic systems and our environmental systems. So anyways, I'll set that aside. Go back to the building codes, because that's...
Certainly, and I'm starting to get into this. So just to give an example, we're looking at thermostat data from Ecobee again, because they've been nice enough to make their data public. And so for the first time ever, we don't have to ask people, what set points are you using? Because we actually can look at what set points are you using it for tens of thousands of people. And so I'm working with NRC to look at, should we adjust the National Building Code assumptions about occupants? I mean, I know this is relatively obscure compared to your bigger question, but it's just an example of the work I'm doing, using data to try to inform policy. Your question is a great one. I think it comes down to lots of pushback from, the way things are done and costs and so on. And of course, as much as people like us want to, push things forward, there's people that are invested in pushing them back, right? People who have to pay for the first costs primarily, or the homeowners, right? I look to my hometown of Toronto, where the average house price is now more than $1 million. I don't know if I would want to add even 5% to that. If it means that I'm suddenly priced out of a home because there's a few efficiency measures. So I'm not trying to suggest that that's a good attitude at all, but I'm just trying to play devil's advocate. You could start to understand the economic interests behind building codes.
Yeah, so I'm so triggered at the moment. My head's going to explode. So to Robert's point, you always have to ask yourself, as my father would say, this sounds like a you problem, not a me problem, right? So the problem is property development is about incentives and disincentives, right? As you were talking about there, right? Who owns the problem here, right? If you build a shitty condo and half of it's got cheap glass and you can't sit near the window at winter, not anyone's problem except the poor sucker that buys that. Right? And the poor sucker that buys that has been hypnotized into thinking that his residence is an investment, which it's not, by the way, at all. It's a failure of planning policy and to put enough supply into the market, right? So there's that. So how do we break this cycle of abuse? Because that's what it is. This is a cycle of abuse where bad work, the construction industrial complex can get away with just putting up dog shit and having people crush each other to buy it, right? So there's only two ways to do this. One is a libertarian solution, and the other one is a Trudeau solution. So the Trudeau solution is, let's really change the building code, properly, with no lobbying. That's never going to happen, right? But let's just pretend there was a world where lobbyists went mute for a year, right? And you change the building code to be performance-based. That's one way. Or the other way is we have to put enough knowledge out there, and this is probably where universities come in, that people start demanding the real thing, because that's a market-led solution. And there's no way anyone else can fight that, because ask BlackBerry how it turned out when the market, aggregate demand is the superpower of everything, right? Tower Records, BlackBerry, Virgin Records, none around anymore because literally no one cares. The people moved on. If people could move on from shitty condos, the market would change overnight, right?
Yeah,
absolutely.
For sure.
And I look at some of these towers going up and I ask myself, how did that even meet the code? I don't know if the problem is totally the code, but the fact that somehow it's not enforced or there's loopholes. But to see these glass towers with, continuous slab balconies, how? Who approved this? I don't know.
The Condo Act in Canada is legalized consumer abuse. There is no other way to describe that. That thing would not get a reading in the UK. I don't know. The Canadians get so screwed by companies here. It's just amazing to me. And I've been here 15 years and I'm still jaw dropped at what goes on here.
And as my supervisor wrote in an article, you may have seen it, it's something like condominiums. They put the condom in, condominium or housing or something because it's screwing the consumer. I didn't quite get that right, but it was quite cute and blunt.
The answer is, don't buy these units. Demand something better, right? Use the power of your wallet to affect a change, because that's the most efficient, quickest, powerful change in the world.
Yeah.
Right. And one of the things we've done, because I often wonder, why do people want these huge windows? Like, is it because you need a sense of space, or you want more daylighting? And so I've had I hired a student to photograph one of these buildings for many days. I paid her well. I mean, it's not the most glamorous job, but what we noticed is that the bigger you make the windows, the more the blinds are closed. So you give people the big windows, but then they just cover them up. And it's hard to explain.
We talk about this in one of our courses, in our integrated design course. We say, you know what, if you and look at some of these condos, there are some serious assets inside those condos in terms of paintings, artwork, woodworking, whatever, that gets imported. If you went into any museum anywhere in the world, anything of any value is not subjected to shortwave radiation, right? The humidity is controlled, the ambient conditions are controlled. But these people are buying $1 million condominiums. They're putting up their valuable assets and they're exposing it to this shit, sunlight, and they haven't got a clue what happens. And then after a while, they figure, well, why is that thing starting to turn yellow? Well, why is the jointery in our imported Indian cabinetry all of a sudden starting to fall apart? We don't teach them that, right? And no one that's selling the condo is going to talk about it. They're just saying, look at this beautiful view. Ultimately ends up wrecking the stuff inside. And like your student figured out, they close the blinds anyways. It's just like.
Yeah. And then comfort might be okay when the HVAC is running. But what if you lose power or the system breaks down?
Oh, you're
on the top floor. The space is overheating. What if you don't even have the ability to climb down the stairs?
I'm glad you said that.
Some liability there.
Every time, everyone's going, we're going to electrify this building 100%. And the engineer in me thinks, where's the resilience in that? Right? What happens when
that's a landmine. I mean, people are stepping into landmines all the time, and this is the difference between an engineer, right, buying shit, and someone who's got googly eyes for the architecture, right? So when I moved into my office condo here downtown Calgary, right, I told the person who was representing me what I wanted. I wanted a north side, northeast facing, right, middle of the building or up to the 2/3 of the building, right? And she's looking at me going, well, what? You're going to lose the view of the mountains and all that kinds of shit. And I said, look at the sun patch here there, like it goes from this side of the world to this side of the world. And so for like 12 hours of the day, everybody on that side of the building's like a fish in an aquarium. So I don't want to be the fish, right? So now when it gets like in the middle of summertime, right, when the sun's blazing through those windows and those people like freaking complaining that even with their air conditioning systems, they're baking, right? I'm sitting out on my patio with a nice beer and just things are good.
Absolutely. But one thing I want to point out is that inherently MURBs could be much more efficient than detached houses, right?
Yes.
And the data say a little bit otherwise. But I mean, you have less exposed surface area, you have less materials overall, you provide a way for people to live more densely. Like personally, I don't even own a car. I live downtown Ottawa. The amount I save by not having a car and by renting my parking space out, I think that could more or less pay for my retirement. It's a slight stretch. But anyway, like I live much more sustainably because I live in a dense area. So I don't want to poo-poo MURBs because the potential is there, and like sprawl is a disaster in Canada, whether you're in Toronto or Calgary. And
Uber.
One more pet peeve, and then I'll turn it over. But I see a lot of sort of net zero energy houses, efficient houses being built so far from civilization, and I just think you're offsetting all the goodness by kind of moving your emissions from the house to your car, because now you're going to be dependent on multiple cars.
All right, so I've got a challenge for you. I personally think universities as thought leaders should be more powerful than they are. Right now, I know there's all funding and tenure politics, and there's all sorts of like Game of Thrones politics goes on in universities. However, you ever heard of a professor called Scott Galloway? He's professor of marketing at NYU Stern.
I have not.
Oh, he is hilarious. He's mouthy. and his whole thing is further education is just ridiculously high. It's become a luxury brand, and he's trying to change that. And yet they still employ him because he's become so big they can't fire him. Do you know what I mean?
I love it.
But he's trying to affect a change, right? So you should be the Scott Galloway of buildings. You should. Whether you can do this within the confines of university, I have no idea. So I'm riffing here, right? But why can't you be the Scott Galloway of buildings and be the person who's the thought leader? He's on every podcast being mouthy, saying, I'm challenging the building code people to do this, and then go to the building code people and shame them into doing something. Because that's one way to affect change. You become this big person that people can't ignore, and it becomes embarrassing because you're shaming them and they're ignoring you. Do you know what I mean?
I love it in principle. And I'll say no one is holding us back. I mean, I think professors have far more freedom than you can probably imagine. So I love it in principle. I have a habit of sticking my foot in my mouth and saying the wrong thing to the wrong people.
That's fine. See, look, what I try and do with my blog, I am so frustrated with the state of the industry. I've spent 40 years in it. It drives me crazy. The way I stop myself going postal is I blog about the absurdities of it. I'm just a freaking lunatic idiot. You're a professor. You could actually maybe affect change. No one's listening to me. I'm just talking to myself most of the time, right?
Well, when you think about like Ted Kessick and Kim Purcell and yourself and John Straub and Steve, I mean, we actually have some, collectively some pretty strong critics about the architectural community and building and property development. The voices are there. I don't know somehow we have to get those voices collectively to sit in front as a panel in front of the voice or in front of the authorities, those that are holding us back. And it's time for a 2x4 to the side of the head, frankly. I mean, we've already left a legacy of architecture that's bad for the next generations to come. I mean, there's no avoiding it. We can't. I don't know how many billions and billions of square feet of bad architecture that exists. It's not the new shit that worries us, as we all know. It's the old stuff that's, we haven't, it's infected. We're in a pandemic, people. We have a pandemic of architecture. It's killing us.
Absolutely. And the leg, as you kind of inferred, is the big problem, right? Because we're stuck with yesterday's architecture for decades.
So look, before we go on to the wrap up, short fire questions, I just want to plant this idea in your head. I believe people like you who are leading research, teaching young people, right, before they go into their careers, you have a lot more power than you realize. You have a lot more influence than you realize, way more influence. So I challenge you to Google Scott Galloway, be that dude for the built environment, man. I'll be all in on that. I'll bayonet the people behind you. Give you back cover.
I will do that. I promise.
All right. So we're getting, unfortunately, we're at the end of our time here. So we have some, Adam calls them rapid fire questions. Yeah. So Adam, what's your rapid fire question?
Well, based on your unrealized power, what advice do you give to someone who's you've had them for say 4 years or 2 years, whatever their length of study is, you've been molding them and you're kicking them out into the workplace. What would you like to see them do? What advice are you giving them when they go?
I'd really like to see them be influential. I think it's one thing to, be a handbook engineer, but it's another to really change.
Love that.
That's the money shot.
The handbook engineer.
But I mean, there's a tendency, especially in other fields of engineering, to be handbook-like engineers. But I think buildings, especially building systems and energy performance and comfort, cannot be treated that way. We need to look at them in a custom way and understand all the interactions. And you just can't put that down in a handbook. There's no handbook that can force you to, consider all these connections. You need a human with intellect to be able to do that and convince everyone that that's important.
Yeah, I like it.
Yeah, Liam, I think, did you mention you said you had kids or
No kids.
no kids, grandkids, or nephews, nieces?
I don't know how that would work, but sure, I have nephews and nieces.
So let's just say, for example, that your nephews and nieces are all like I just say they're 12-year-olds, 12 to 14-year-olds, right? And you're sitting there, like an oracle. You've been invited to their classroom. There's 100 of them, little boys and little girls, their future's ahead of them. What do you say to them about architecture and engineering and the future of the planet? As what kind of message do you want to leave those little kids, those little minds of theirs?
I would say there's a lot of room for improvement, and it shouldn't be that hard to improve the status quo, because even applying today's technologies would be a huge improvement over what we're doing now.
Yeah,
absolutely.
Well, ultimately, time, as everybody knows, goes by really fast, and all of a sudden those 12, 14-year-olds are 24 years old, right? 10 years goes by, and the buildings that we have in inventory are 10 years older, and energy changes in terms of its cost to convert it and use it in buildings. And so somehow we have to have faith that these little kids, these little minds, will solve the problems that we created for them. And I think the future, for the most part, is looked after itself. We, like you pointed out, we have the technology. It's applying it.
Yeah.
We don't need, in fact, we could stop doing research work today on just about everything and just apply what we know, and we would solve 80% of the problems, right?
I would totally agree with that.
Yeah.
And, the other thing I wanted to say today is that in Canada, in North America, we have huge buildings. Like, the amount of square footage per person is insane. Like, if I look at my family, my mom owns a big house in Toronto. I own a small townhouse in Ottawa. With my wife, we have a cabin. She has a cottage. It's like, this is insanity. So it's not just an energy efficiency matter per square meter,
right?
Also per person. And I think we need to make better use of our buildings.
Yeah, I think, I've traveled a lot and I've lived overseas a lot. And what struck me when I moved here was how spoiled really Canadians are in terms of like natural resources, space. Just the amount of space here is just mind-blowing to most people. When you go and see how other people live, this place is goddamn nirvana, but no one knows, right?
Yeah.
No one's aware of this.
And if you look at the energy efficiency gains in Canadian housing over the last 3 or 4 decades, I think it's about half been eaten up by bigger houses, yes, which is a real pity, right? And so on the one hand, maybe we're living better, but if we look at the total emissions and energy use, which is really what matters, there's a problem there.
So my last, sorry, man, go on.
Well, we keep talking on this stuff, but there was a trend line up until the housing crash in the U.S. Where the square footage per person was going up, and you had like people that were building. In the beginning, it was the 1,400 square foot war house or 1,200 square foot war house and a family of 7, living in it. And then, here we are 30 years later, 40 years later, and now it's, 4,000 square feet for less people per square foot. And that trend continued up until the housing crash. And then there was people, including myself, I thought, okay, well, maybe now people will begin to realize just how screwed that up is. And there was, for a period of about 1.5 years, 2 years, where the housing industry was recovering, where the square footage per person was going down. But that only lasted as long as the economic recovery, because as soon as the economic recovery took over, we're back on the trend line again.
If I go walk down the road here, every other car is an F-150. Any country that there's no F-150s in Europe anywhere. Do you know why? Because you can't afford to put gas in them.
And you can't park them anywhere.
And you can't park them. You know, a Canadian is like a Canadian who lives in a 3,000 plus square foot mansion with a pool and F-150 saying, I'm worried about the environment. It's like a really fat person, you know, ordering a double Sunday split and convincing themselves they've got glandular problems. You know, it's just, it's self-delusion, right?
Yeah.
And then throw in COVID, and now everyone thinks, you know, they're going to be working from home forever, which is probably not true. I hope. So now they can justify a bigger house that's like, you know, 100 kilometers away from where they used to work.
That's going to be an unintended consequence of this, for sure.
Yeah, that really concerns me. Beyond, you know, traditional measures of environmental impact, like, you know, land use and greenfield development, you know, is a problem that we need to appreciate in Canada more.
Yeah, actually, it's going to be really interesting, like 5 years from now, and seeing how that all played out. Because I think you're right. There's going to be it's not going to be, cities aren't dying, right? But they're not going back probably to the vibrance and density they had. And you're going to get this spill, even if it's a 5 or 10% spill to the suburbs. That is a massive environmental footprint.
Absolutely, considering the much lower density than city of Toronto, for example.
The incidental journeys, the incidental gas use, resource use, it's freaking frightening, actually, if you did the numbers.
Yeah, and I know we're out of time, but I am doing a study looking at this. So we're measuring, for now, just 10 people's activities and, you know, driving, transit, household energy, office energy. We're trying to measure this.
Well, when you've got that all wrapped up, come back on and we'll talk about it, because that is fascinating, man. Because again, people, you don't know what you don't know, right? You're a fish in a bowl, you don't know you're in water. And part of the solving this problem is putting information out that's digestible, that people can understand what's going on. And that doesn't happen really very well.
Absolutely.
That's on you, by the way. Anyway, listen, Lou, thank you for coming on. That is great. I've been, well, like Robert said, I've been stalking you like a crazy ex-girlfriend for a while now. Love your work. It's been great to talk to you, and I'd love to have you back on. If you've got a paper you want to talk about, you just give us a call. We'll come back on, man.
That'd be wonderful. This was a fun time, and it went so fast. And I'm an avid listener, so thanks for all your work.
The Edifice Complex will continue in just a moment.
Adam, it's time to thank some people who are on our side. Blue Rhythm commissioning software.
Blue Rhythm is the commissioning software I've been looking for. Most projects I consult on suffer from poor information and document management. Frankly, it's just chaos out there. Blue Rhythm removes this chaos. It is a secure, always available cloud solution designed to work on any computer, tablet, or smartphone. Their Android and iOS apps allow seamless transition between online and offline work. But what I like most about Blue Rhythm is their painless and fast onboarding process. Our team will bring all your existing forms and checklists into Blue Rhythm for you, or you can use or adapt their pre-built, pre-functional and functional performance test sheet templates. But it's more than that. It enables collaboration, automation, and easy planning and project management for all your projects. Blue Rhythm provides amazing support from a team that really understands your industry. To find out more, go to bluerhythm.com or call country code +1 612 460 8305. Also, you can hear from Blue Rhythm President Andy Martin on episode 26 of the Edifice Complex podcast. Robert, are we there yet? I'm bored.
Adam, I know it's hard to believe, but the future has finally arrived in Canada.
How's that then?
Well, smart remote building and equipment management is now available from SensorSuite.
Go on.
SensorSuite, yep, they're an innovator in smart building technology. We like them. They can monitor, control, and optimize anything in your building, saving you time and energy.
You mean SensorSuite are moving Canadian buildings into the 21st century?
Yeah, I know, another hard thing to believe, but they're doing it, and they're saving owners money with efficiency gains.
Okay, I'm in. How do I find out more?
Got to go to sensorsuite.com or call 1-855-773-6767. And also check out the July 2020 episode of the Edifice Complex podcast and listen to SensorSuite CEO Glenn Spry.
And now, back to the show.
Adam, that was, I love those interviews that we have where we have people that are willing to speak up and out and against stuff. Leah made some great comments. Right off the bat, well, I know how you feel about teachers and the ones that have inspired you, as I have been inspired, by past teachers. And we were just talking about before we did the wrap here, though, how you had a history teacher that left an impression on you as a young man.
He's quite a humble guy. He's getting on with his research, but I don't think he understands how much power he has, how much influence he has, is probably the better word. I remember all my great teachers. I have an interest in history because a history teacher I had when I was 13 got me interested in it. And I still remember her to this very day, right?
Yeah.
I'm 57 now, right? So you do not forget good teachers, and they influence your thinking and career trajectory, even if you don't know it, right?
Yeah.
This is one of the reasons I love what we're doing, because people like Liam, Peter Simmons, people need to know about these people so they can go to them for advice, for guidance, just to model themselves on them, right? Because being a great teacher is also about being a role model and influencing thought and asking open questions and letting people run with it, right? That is great teaching, particularly when you're at his level. So again, but it's unrealized because academics are normally quite, sort of like inward, introspective, just bogged down in their research. They don't understand the communication power they have.
Yeah, it's massive. I'm with you. Like when I think back to the teachers that I've had over the years, and same thing. I was like 13 or 14, and I was inspired to study the Cuban Missile Crisis. I mean, I was more interested in girls and hockey and, but somehow this guy got it into my brain that this is something you should look at. So I did. And you know what? It was fascinating shit for a 14-year-old brain that was more interested in chasing girls. He said something early on when we asked him about his origin story. You like to call it the Spider-Man stuff. And he said, when he went into the space sciences, he said, well, Earth is boring.
It's done.
We've solved all of the Earth issues, so I'm going to go look at space. And then he came full circle, obviously. And as you can tell from the interview, that he very much sees that Earth is not boring, and what we do here on Earth is very important stuff, particularly as it relates to architecture and buildings and property development. And it's cool. Like he said, space is cool, but so is building science is cool. And he represents coolness in the studies and stuff that he's doing. And he also made a really good point. And that was that the aerospace studies was a good background. And then we've said that before over and over and over again. And it doesn't matter what gender you are or from what part of the world you are on, because we've interviewed people from everywhere, that the science is STEM education allows you to transfer your knowledge to any field.
Yeah. I mean, you could do an aeronautical degree and think, oh, I didn't like that. And it's a sunk cost, but it's not, because the level of math and number crunching you're doing there, you can apply it to data analysis, to engineering, electrical engineering, mechanical engineering, right? There's a pivot there that's probably easier than most pivots most people could make, right?
Yeah. So it's, we're really encouraging people to get that STEM education, whatever it is, and never see it ever as a loss, or that you call, the sunk cost, but I think is a great analysis. It never is. When it comes to STEM, if you were bitten early by the interest in the sciences, and that stays with you, your academics are transferable to adjacent fields, which is what our podcast is about. It's about the adjacent stuff, right? And we've had many guests on that have that STEM background, that have moved laterally, up, down, side, whatever the direction, and they were able to continue on with their passions, which was what this is all about.
Yeah.
Find your passion and feed it.
I loved his adjacent thinking in mining that ABnB open source data.
I was just going to mention that.
That is genius.
Right. And so, but he said that came from his own life experiences, which was really important. That we can't underestimate that statement. The life experience that he had being in a B&B, and then thinking to himself, well, there's reviews on these things. And then his student, Hannah, coming up with the ability to 1.35 million reviews.
Yeah.
Kudos to her, man. And what they got out of that was valuable stuff. But he also made a really good point too, is that, like that's a lot of data to cover, but actually reading, so there's the macro data.
Yeah. And then
right?
the drill downs.
Then the drills down. And he said, oftentimes you get more out of looking at the reviews than, the micro stuff than you did out of the macro stuff. I thought that was pretty interesting too. You brought up always again, I always like the comments that you have, this chaos theory that you introduce. You get your three-legged stool there, and you can do all of the facility management and the architectural engineering shit, and then you put in the human factor, and it just gets chaotic.
Oh God, yeah, man. Humans, we are just chimpanzees looking for a gorilla. It's just chaos. This is the thing, that going back to that super sustainable job I did, where I thought we'd nailed it, right? And the human factor just wasn't. It wasn't that we didn't design for comfort. We didn't factor in how to take people with one cultural experience,
right,
and then ease them in rather than just drop them in and go, have a nice day, enjoy.
Sure.
So that was my real lesson learned. Ever since then, when I've worked on anything that's sort of different or super innovative or super sustainable, I always make a point and advise people, you've got to get people in a room and explain to them what this experience is going to be like. Otherwise, you're going to get callback after callback after callback.
Yeah, you really have to set the expectation and lead them through that, so that what they're experiencing, they have an awareness, even if it's an intellectual experience, rather than a physical experience, that they understand. Okay, well, we were told this is what's going to happen, and we were told that this is going to take some time, and so it's not a big surprise.
But
right?
You also get the opportunity to explain to them the benefits of having this experience.
Sure.
One is like, obviously it should be more comfortable once you get used to it, but two, there's a big cover over the west window here, and we're saving 35% of our cooling load here. Now, that don't mean anything to you, but to the environment, that is, and you could put that in, that's X trees, that's X cogen, right? There's a educational opportunity there just to push that needle a little bit, right?
Yeah.
And have people think about it.
Yeah. I've used the analogy before that, when you think about a small village, where the mode of transportation is a jackass, a donkey, right? And then along comes this guy on a girl on a horse, nice stallion, whatever, mare. And so you're looking at your donkey, and then you're looking at the horse, and you're looking at the donkey, you're looking at the horse, and you're going, why are we riding donkeys, right? Well, we have an architectural community of inventory buildings that are donkeys. But we also have now started to build up a barn with enough thoroughbred horses that we know what good buildings are supposed to be. And we can make the comparison to the jackasses, and we've been living in jackasses buildings for a long, long time, but we have now people that are living in the thoroughbreds, and, so now there's a comparison. And so, we need to actually expose the jackasses for what they are, and let more people understand what it's like to be living in a thoroughbred building. He also made a comment, which I love, the handbook engineer.
Oh, I was just about to say that. I love that. That's the mic drop. Just have a nice life, have a good career. Liam out.
Yeah, totally.
But you can see why people do it, right? Because it's defensible. I did it by the book, and it's what we've done in every other building. That is the logical thing to do if you're an engineer, right? You don't get sued. You get less callbacks. You can move on to the next job quick. It's formulaic. There are so many incentives to be a handbook engineer, right?
Yeah.
And you gotta, to crack that nut and change that, it has to be a demand-driven thing. Someone has to say, no, I don't want a handbook job. I want a proper job, right? And I want these factors.
If I had it my way, every researcher academic researcher in the building sciences, or maybe in any field of study for that matter, before you're allowed to do research or before you're allowed to write a research paper, you need to have at least 2 years under your belt in an application world, either doing facility management, commissioning, whatever. But you have to be able to take your academics and put it into real world practice. So when you start writing those research papers, that there's a real world experience to it. Because Adam, I gotta tell you, man, I'm involved with a lot of academics through my work at ASHRAE, right? And we read research papers all the time. You can tell a pure academic who's never been in the field, never commissioned a system, has never learned how to actually even design a system, but they're a handbook engineer.
Yeah, absolutely.
They're the quintessential handbook engineer, and they will tell you, from their research work, this is how it is, and this is how it should always be, and that anybody else out there, again, I want to use a foul word, but the reality is they're so out of touch with reality that the statements that they make in the paper might apply to the paper, and in their little world, that might be a true statement, but in the real world, it doesn't wash. It doesn't hold water. And that's the difference between a handbook engineer and an application engineer.
This is why I always go back to our field of engineering is applied, with a capital applied, right? Bold, underline, quotes. And this is where people like Liam have the ability to hammer that home. He sounds like he understands that. But there's a lot of people in this position that actually don't, I think. Yeah. So again, his ability to influence things is amazing and unrealized and probably underestimated and unknown to some degree, right?
Yeah, I agree.
I'd love to see him turn into a Scott Galloway type figure where he's just like that guy and he's so loud he can't even be put down. He's sort of uncancelable, But it's not a place for an academic, right?
True enough.
Yeah, but
But in many ways, you and I we're fortunate because we're semi-retired, retired type of stuff, and we've been through our career. No one's going to fire us. We can say whatever the hell we like. And we do say whatever we like because there's no consequence anymore for us to speak our mind. No. Even when we were in our careers, we did that, and oftentimes got into trouble.
Sometimes, if I was like 20 years younger, you could make a comment here and get called into someone's office when you go in and work Monday. Think, Adam, we're working on this job. I don't think you should be saying that. That happens, right? This is the beauty of. You've either got to not care, really not care, or be towards the end of your career and be uncancelable, right? Because powerful people don't like change. If you're a contractor and everything's going your way and handbook engineering works for you, why the hell would you want to change? You don't want to change. Right?
Yeah. I remember one lecture Joe Steebrook gave from Building Science Corporation, and I think it was in Seattle or someplace like that, and there was an architectural academic person in the audience who took Joe to task. So you have to picture this, okay? So you're in a lecture theater, right, where he's down on the floor and everybody's looking down on him, right? And he is the oracle of building sciences around the world, and is happy to use colorful language.
Yeah.
Not a problem, right? Joe will use colorful language, and this guy takes him up on his attack of architecture. And I love Joe just like,
hold my beer.
Like, oh yeah, he just tore into this guy in front of his 99 other colleagues, and to me, I'm listening to this, I'm going, good on Joe. You need to set the world straight, and you know what? You can't fire him.
Yeah.
You're not going to be able to. He doesn't. Yeah. People from all over the world will hire him, so it's not about money. It's not about contracts. It's not about that. Joe is doing that because he wants to change how we do shit. And if you're going to get up there and from a pure academic point of view without having any scrapes or bruises, you got no war wounds, you've never stepped your foot into a landmine before, just shut the F up.
Yeah, exactly. Yeah. I couldn't agree more with that. But I tell you, Liam, that was a good interview. I like him. I love his work. And he's sort of relatively young. He's got a lot of runway there. Hopefully he's going to change a lot of minds and influence a lot of minds as he goes forward.
Yeah, so we have to clear the field so guys like that can keep running those runways.
Yeah,
because
absolutely
he's got
right.
another 20 years or whatever he wants to do,
Yeah.
make changes, right? So,
Okay, man.
Adam,
Great interview. See you.
for the people that are listening to our podcast, because we have now a good following and people who are regular listeners, we're building up a huge resource here, assets of people's thoughts, their opinions, and we, again, just a reminder to the parents that encourage your kids, your students to listen, if not the whole podcast, at least to our wrap up. And if the wrap up, because in the wrap up we do the summaries, and I got to tell you, man, we have a lot of great advice that have come from the people that we've talked to.
Yeah, God, I wish I'd known half of this stuff when I started out.
Do that.
Okay, take care. I'll see you in the next one.
All right, man. Cheers.
Bye.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.